Okay, now I heard you talk about the carbon-based heat shield.
Yes.
So can you tell me a little bit more about it?
Sure. So I'm Betsy Congdon. I'm the lead engineer for the thermal protection system for Parker Solar Probe. Thermal protection system is just a fancy way of saying heat shield. The heat shield, which will sit on top of the spacecraft, and it will always be between the spacecraft and the sun when we're doing our science, is an 8-foot frisbee, as we like to call it. It's about 8 feet in diameter, but only about 4.5 inches thick.
So Greek mythology did say they don't fly too much.
Okay, now are there any similarities between this heat shield and the one that was on the space shuttle?
So a lot of the materials that were involved in the space shuttle show up here on the heat shield, but it is quite different. The heat shield did use ceramics and carbons, a lot like this heat shield did, but this heat shield is more structurally sound. So it actually takes the load of the launch itself without any backing structure, which on the shuttle there's actually like a backing frame that all of the tiles were bonded to, and this is actually structurally integrated, and so it's a sandwich panel that can take the load of launch as well as the heat of the sun.
So the panels, is that the actual size of the panels?
So yes, so it is 4.5 inches thick. I mean, I can pick up one of them if you would like. It is 4.5 inches thick. That is the right thickness, and then obviously it's just a little small cutout, but that is what that's the real materials. That's really how it's put together.
And how do those attach to the ship?
So there are 6 attach points at the top, and that little bump that you see on the heat shield sample there actually is where we cut out and bolt a plate that then interfaces the rest of the spacecraft. So we keep only 6 attach points to keep down the conduction into the rest of the spacecraft.
Okay, so it is bolted, not a bolt.
Yeah, ultimately the heat shield is bolted. Nikki, I'm not sure I trust you with that.
You let me hold it while you're ringing. Okay, you're ready. I'm going to get out of the box.
Okay, anything else you can tell us about the heat shield? Is it flexible at all?
It's pretty rigid. It's basically like that rigid frisbee. That's really what it's like. So not very flexible, but it does. We like to think it smiles at the sun. It will, the top face sheet expands and the bottom face sheet doesn't expand quite as much, and so it will actually take like a spherical shape. And we say it's smiling at us when it's at the sun.
Now, is this the same one that's going to be on the top, like the umbrella?
Yeah, so this is what the heat shield that will go on the top. I mean, this is not the actual one. The actual one's at the Applied Physics Lab, but this is very same construction, all that of the real 8-foot one that will go up where that red piece is right now.
And is there any about any space?
So we do have models of dust, which is like at the sun, and we go through a lot of simulations of what would happen if something were to hit it, and that's part of the engineering that goes into designing this shield. Is all of the environments, one of them being dust, one of them being the radiation, one of them being the heat load. There's all sorts of environments. That's just one of them. So yeah, we actually think about that.
How big a hole can it take without affecting the mission?
So it's not really how big of a hole. It's not really how to think about it. But basically, we've looked at what could happen to it, and we have shown that that nothing could affect the actual outcome of the mission. Nowhere near what we know will happen to it.
And has there been any studies on any comments that might have some that will be during the mission?
So that's one of the things that we look at when we look at the kind of the dust environment, is that type of thing. And so that's all been modeled as part of thinking about how to do this mission, not only for the heat shield, but for the whole spacecraft. Yep.